Okay, so for our experiment, we took a four-wheeler, and it was already going pretty fast. So then it started to decelerate, or accelerate with a negative value. And so it was going fast, and then it started to slow down. And then it came to the end, and it reached 0. And then it started slow, and then it started accelerating.
Took the times at 0, halfway, and all the way there, and we used that to create this formula up here, like finding the velocities at those times and doing some magical stuff with the calculator. Okay, so we took the derivative of the position time function to get the velocity time function. So you multiply 2 times negative 0.98, which is negative 1.84 t plus derivative of that is just 31.95. Then that's 0. So there's your velocity time function.
Okay, to find the acceleration, you take the derivative of the velocity function, and that is the second derivative of the first function. But to take the derivative of the second function, you just take the derivative here, and that is negative 1.84. Okay, so our first question is, what is the velocity at 10 seconds? So to find that, you take your velocity function and plug 10 in for the time. So your derivative of 1.84 times 10 plus 31.95. And that equals 13.55 meters per second.
Okay, so our next question was, what was our average velocity in the first 10 seconds? And this is the formula for average velocity. So you plug 10, which is the b, in for the position time function. Okay, so the answer to that is 225.14, and then you subtract it from f of a, which a is 0 because it's your initial time, and you would just get negative 2.36, so that'd be plus 0.36 over 10 minus 0. So is 22.75. And this is your average velocity. 22.75 meters per second.
Okay, so we're trying to find out what time that we change direction. So what you do is you take the velocity, and set it equal to 0, and that's basically when you change direction. So you have 0 equals negative 1.84 times. And so then once you solve that, you get 17.36 seconds for t, and that's when we change direction. So the next question is, what is our displacement when we change direction? So you take the time when we change direction, which was 17.36 seconds, and then you're going to plug it into, for the time right here, to get the displacement when you change direction. So And when you plug that all in, you get 275 meters, and that is your displacement when you change direction.
The last question is, what is the acceleration at 15 seconds? And acceleration is the second derivative of the position function, which is negative 1.84, and the acceleration is constant the entire time.